So it's basically from composites until finished yarns and until finished portraits. And in Augsburg, we are a small, is that better? Yeah. So in Augsburg, we are a small group of researchers of 15 people focusing mainly on 3 different topics. The first one we started with in 2015 was the recycling of composites. So it's a lot of carbon fibers and glass fibers. We call this web-based composites, where we develop processes how we can regenerate the carbon fibers and put them into new products again. The second part we're focusing on is artificial intelligence. On artificial intelligence, we equip textile machinery with sensoric to be able to predict the quality of the product coming out and also to understand better the textile process. And the third part I'm going to talk about today is the so-called recycling atelier, where we focus on the mechanical recycling of textiles. It's not working. Okay, if I click here, it's working. So we heard already today a lot about that we have a problem of textile waste. And it's quite a lot. In one study, we tried to find out how much it is, and we tried to focus on Germany, but even in Germany it was not possible because the numbers are not quite there, and we don't want to produce any zombie data. So what we did is to do some estimations. And we say we collect around 1 to 1.6 million tons of textile waste garments separately through our textile banks. And in total, textiles is not just garments. We have technical textiles, we have hygiene products. So we estimate that alone in Germany, we have 4 to 5 million tons of textile waste every year. And this is causing a big problem. And of course, what we're trying to do is to develop a circular economy for this textile waste, to use it. And we are also realistic, so we know we won't be able to achieve a perfect circle. So we kind of created our circular economy and textile waste a little bit different with the infinity sign. And you can see basically 2 circles there. The right circle is a circle of reuse and reduce. As long as a textile is still usable as a textile, we should do that. So to be able to do that, a big part is how can we collect and sort the textiles and able to make the decision if it's still wearable. Also, the right part is mainly produced by the consumer. So the consumer can make this decision, and that's where the consumer can have a very, very big influence on sustainability in textiles. But no matter what we do, at a certain part, a textile is not usable as a textile anymore, so it's at the end of the use phase. As soon as it's the end of the use phase, we have to go in the second cycle, which is the left one, where we think about recycling. And as soon as we think about recycling, we have a lot of different recycling technologies. But still, we have to follow the waste hierarchy. And the waste hierarchy says clearly reduce, reuse, recycle, but also in the recycling, there's a difference between feedstock and material recycling. So mechanical textile recycling, as you can see it here in the front, is a so-called feedstock recycling, where we don't reduce our materials into single atoms or polymers, but we use the textile fiber as it is. Of course, we have a little bit of a problem for the fiber length and therefore for the quality. So we also need to think about chemical recycling and different recycling technologies. But we also know if we have such a big amount of waste, we need a lot of recycling technologies for a lot of different kinds of feedstocks. So that's what we're trying to do. And we, in the recycling atelier, we focus on the mechanical recycling first because it's on an industrial scale, the technology is there and it's not new. So we sat down and think, okay, what could be our part of making this vision happening? And as researchers do, normally we apply for funding, and we did. And we applied and we got rejected because of legal reasons. But still, we recognized that it's a big issue. The industry needs solutions, so we didn't stop and think about new concepts. And as the most people of you know, mechanical textile recycling is not a new technology. It's there for 100 years. So our question was, why is it still not on the market? Why is there still 1% recycling? Of course, there's a lot of economic reasons, but also technical reasons. And that's why we came up with the concept of a maker's lab, as we call it, which is a small factory where we have the whole process chain from collecting until finished garment under one roof. This is necessary because producing textiles is very complicated, and we have a lot of process steps and a lot of different companies which are located on 3 different continents in 5 different countries. And to be able to make this circle happening, we need to connect the single steps. And that's why we came up with the concept of a maker's lab, where we are able to put the product first. So if we think about recycling, we have to think about a product which is economically, ecologically, and technically feasible. So we always have to think about these 3 points. And as soon as we have the product, then we start to design the process chain. And that's what we are able to do in the Makers Lab. By being flexible, by being fast in prototyping, we are able to think about the product first and not about the process. As soon as we have the product, then we develop the process for it. And the second point we have to focus on is upcycling. So upcycling is a misleading concept. You can say upcycling is just by stitching on new patterns on the holes of your garment, but it's also that we need to think about quality. So at the moment, textile recycling is only into low quality products. And what we need to be able to do is fiber to fiber recycling to give the economic value back to the fibers. And that's what we're focusing on the recycling atelier. And then if we produce new products, of course, we have to align them to be better recyclable. So it's about the word design for recycling is a lot of the key issues. As soon as we start recycling, we learn more and more about what's our problems. And as soon as we recognize the problems, we also have to think, how can we design the garment different to not even get the problem and to make it easier to recycle? And the last part is, if we want to establish a circular economy in the textile industry, we need to educate the people. So that's what we do. We are an institute, so we are also doing lectures with a lot of students working with us. So it's a learning factory. We need to educate people who are able to think in circular economy. And for this, we founded in June 2022 the Recycling Atelier. And this is the first picture we had in mind now nearly 2.5 years ago, which is now reality. But what we're trying to do is we divided the process of the mechanical recycling into 7 different process steps. And we start with the first one, the material analysis. So as soon as we get textile waste, textiles are very diverse. So we have a lot of different feedstocks. And what we're trying to do there is to describe what's in it and to be able to follow the quality parameters along the process. The second one is the sorting. The sorting is one of the biggest key issues if we want to be able to really recycle post-consumer garments back into garments again. I'm going to talk a little bit more about this later, but at the moment, sorting is 100% manual work. And this is limited in economics, it's limited in scale, and it's limited in the sorting depth. So a human is not able to detect 100% cotton and 98% cotton. So that's where we need to have technology and automate this process step. The third process step is then the preparation, which is mainly the removal from any disruptors, impurities such as buttons, zippers, labels, and then the defibering into fibers again, so a tearing process. That's where we do also a lot of innovation. And the next part then we divide into the yarn process and the non-woven process, so we call it textile processing. It's either the non-woven line or it's the spinning preparation. And this is one example why a maker's lab makes sense, because the steps 3 and 4 needs to be connected. So it's a question, problem is fiber lengths over the whole circle. So as soon as we start, we reduce the fiber lengths, and as far as we reduce it, the quality gets lower. So what we need to do is to keep the fiber lengths as long as possible. But at the moment, the tiered fibers are evaluated just manual by hand. So there's no standard how to test it. So they are sold by just touching. And what you do is try to have as less yarn pieces in it as possible. But as soon as you do it, you reduce the fiber lengths. But the carding process could do a lot of cleaning. So we tier less, we accept more yarn pieces, but clean a little bit more in the textile processing, so in the carding process, and this is raising the quality. But in a normal value chain, these steps are not connected, so that's what we do here. As soon as we have the textile processing, we go into the spinning process, where we do mainly ring yarns in Augsburg, because we're a research institute, and open end is from the quality a little bit less, but it's still already in the industry, and we are trying to raise this up onto the ring yarns. And then the last step is product design. It's prototyping. I noticed a lot that if I go to designers and brands come to us and say, what can we do in recycling? And I start showing them yarns and talking to them with my technical sense about some yarn properties, they're not getting started thinking about the sustainability. So we need to show them products to get them start thinking, okay, what is possible? That's what we do in the product design, where we have just a small equipment to be able to do fast prototyping. And this process is quite complicated, as I mentioned, and we didn't get any public funding for it. At least we did at the end from the Hochschule, but we came up with a different concept. We call it the partner concept, and all these partners are supporting us financially, but more important, they give us equipment and know-how. So the sustainability can't be solved alone. We need a lot of support. We need a lot of different people coming together, having new ideas, and that's what we do here within this partner concept. That's how I show you. This is how it turned out from the sketch into reality. So we are now able in work. We have the whole process chain available, and I'm going to talk to you about 2 examples now, what we did in research in these rooms, because one big problem is how to get this research into the industry. So in this room, I can do a lot. I can innovate, I can do small prototypes, but it's not going to solve the problem. The problem is going to be solved as soon as we have these prototypes also in the industry in a large scale. So that's also one reason for the partner concept, is we always have one machinery partner and one process partner who's actually doing the process. And they help us staying in touch with the industry and not doing research which is very far away from the market. And that's what we do here. So one project I want to show you is about the textile sorting. It's called Transform Textile Waste into Feedstock. It was led by TextAid and initiated by the Rehabs initiative from the European Union. And this was basically a technology assessment where we try to understand what solutions are on the market for automated sorting and how can we improve them and where are the gaps, which are the next steps we have to take. And for this, we divided the sorting process into 3 main points. The first one is the automated sorting for reuse. So we focused on the textile banks in Germany, where we have only garments. And if you think about a garment and collecting it, the best 10% of the quality have 90% of the economic value by being able to sold, resales, and second-hand shops. And also economically, it makes a lot of sense to keep them in reuse. But at the moment, the process is limited in scale and economics because it's manual. So we need to focus on how we can automate it. The second one is, as soon as it's not able to be used in reuse, it needs to be recycled. And we focused a lot on about what are there for solutions for the recycling qualities. And I know we're going to hear some more from Sylvie today from Picvisa about that. So I'm not going to go into a lot, but mainly the main issue is how can we detect the type of composition? So how can we tell if it's cotton, polyester, if it's a blend? And then as soon as we have detected this, we need to prepare it for the recycling, because we have a lot of diverse textiles, multi-layer textiles, we have zippers, we have buttons, we have labels. How can we handle this? And for this, we looked a lot into different cutting technologies. So what are the main key findings? The first one is that we have a challenge of different TRL levels. So this is especially true for the sorting for reuse. For the sorting for reuse, there is no solution on the market which is able to be on an industrial scale yet. So to be able to present a garment, a camera, to be able to look from all different sides to detect if it's a trouser, which brand, how is the condition, what could be the price for the resell, it's not possible. So we need to do a lot of research there. For the recycling part, we are a little bit more advanced in the TRL. So we have a few different solutions on the market who are able to provide solutions, but we recognize in our testing that it's not there from the accuracy we need yet. So as you have seen in the beginning, we have a lot of recyclers within this consortium, and we ask them, how should we sort? What are your requirements? And with these requirements, we went on testing on the existing solutions, and our findings was that the requirements don't meet the precision of the sorting technologies yet. So there is a gap which needs to be filled. We have the technology, it's able to do this, but it needs to be trained more. So for example, one key technology is NAR spectroscopy. And for this, we are able to detect pure cotton, pure polyester quite well, but as soon as we go to blends, we still have struggles. And this is not because the technology is not capable of it. Mostly it's because it's not trained to do it. So we need more data, we need more data sets, we need more training, we need improvements of the technology. And the second part is to be able to achieve the sorting step, we need to think about the sorting for recycling and the preparation for recycling in combination. So it's a lot about the sorting strategy, how it can produce the requirements of the recycling technologies. So they need to be coupled. That's what we came up with, a different sorting strategy, multi-category sorting first, then binary sorting, and this is combined with the preparation for recycling. But since the technology is not there yet, we started so far with manual sorted processes. And I want to show you what's possible with this. For this, we did one project for the ITMA last year. It's called Walk for Recycling, and Marco was so kind to even bring it to us today. And basically, we started with manual sorted blue garments from the textile banks made of 95% cotton, and started the mechanical recycling process. For this, we started with the defibering. We worked there together with AMI. And as I already mentioned, we tried to TLS, keep more yarn pieces in it to raise the quality. And we accepted a little bit more waste in the spinning preparation, which we did with Strichler. And after this, we went into the ring spinning with Saura. We did some winding. We did twisting, which is a pretty common trick if you don't have the yarn density. And one big issue is there are a lot of imperfections in the yarn if you have recycled fibers, because we have a lot of short fibers in it. And for this reason, we needed to do some twisting to get the strength of the yarn we needed to be able to produce one sweater. And that's the products we did with this. So we produced one sweater which has at least 50% of recycled post-consumer fibers in it. So we showed it's possible, but it's only possible because a lot of people work together, and we brought the process chain aligned. And one key issue we still have to solve is the sorting part, as I already mentioned. And I told you a little bit about the waste in the spinning preparation, but it's only waste if we don't give them another meaning. So what we did is we used the waste to produce a non-woven. And this non-woven we produced mainly about the waste from the spinning preparation. We collected there and we mixed this one with two different fibers, which is viscose from our partner Lansing, and we did some regranulated loopite from the Filzfabrik folder, which is regranulated thermomechanical recycled non-wovens. And from this we produced one bag just to show you can use these non-wovens even to produce products. This is mainly the idea of the recycling atelier, to show there is a use case, it's possible, and to show the gaps we need to fulfill to get to an industrial standard. And for my conclusion, I say circular economy only works through interdisciplinary cooperation. So that's what we need to do, and that's what we are also here for today. And then there is technology there. We need to improve it. We need to keep the fiber lengths, for example, in the mechanical recycling. We need to think about the product first. We need to develop more standards for the testing of the fibers, and we need to be able to show why it's recycled and to prove it. It's still a big point to avoid the greenwashing we heard about before. And for this, the Recycling Atelier is one platform where we bring together a lot of different companies from the textile value chain to all innovate on the mechanical textile recycling. Thank you very much.